Hey everyone, welcome back to eCoreAcademy. It's me again, Ranen and Shakir, back with another video on prealgebra. Today we have least common multiple, as you can see by the title of the video and our slides. As always, before we start getting into this video, please make sure to leave a like, comment, and subscribe, and turn on post notifications, and so we can get more videos out to you guys. And when we get the videos out to you guys, so help our community grow, and we'll help you. So, without further ado, let's get started. So, least common multiple, you've already used this multiple times, no pun intended. So you should already have a basic understanding what this is. So it's gonna be a pretty quick lesson. I'm gonna go through it pretty fast, but we're all gonna go into something that's something you might have not seen before. And which is pretty cool. So we have used it all the time, and in order to understand this lesson, you're going to understand factors, multiples, specifically multiples, which is our one of our previous videos. So let's get started. I didn't have a really good meme. I didn't have a good meme this time. So we have this little corny one. If you don't know where this is from, it's from The Incredibles. So it says there are 7 continents in the world. A triangle has 3 sides. The LCM of 3 and 7 is 21, and 2 plus 1 is 3. Illuminati confirmed. This is really stupid. I didn't find a good meme this time, but the funny part is coincidence. I think not. This is something from The Incredibles. If you haven't seen The Incredibles, I don't know what you're doing with your life, but it's a great movie. Go watch it. Anyways, let's get started. So as always, let's start with some really quick vocab. Only one definition today. So, what is a least common multiple? It is the smallest positive integer that can be evenly divisible by an integer. So, for example, 2 and 3, the least common multiple of 2 and 3 is 6. Because, let's start real quick right here. If we have 2 and 6, we can have 2, 4, 6, 8. And if you have 3, we have 3. 3, 6, and then 9. And then so 2 doesn't work, 4 doesn't work, 8 doesn't work, 9 doesn't work, 3 doesn't work. So the LCM of both, oops. So the LCM is going to be 6. Don't worry, I'm going to explain to this in just a second if that was way too fast. Don't worry. And then, so this is a proper notation, LCM of 2 and 3 equals 6. And this is a nice little chart here. Let's go through it really quickly. So the LCM of 7, 2, 3, 4, and 5 is going to be 420 because that's where they all diverge in the middle. So let's look at an example of, let's look at 2 different numbers and see what their LCM is. So let's look at 5 and 2. We can see that 5 and 2, the LCM is going to be 10, and that is correct. I mean, I hope it's correct. The visual should be right. And then if we have 3 and 7, you can see the LCM is 21. And if we look at for 3 different numbers, we can have 4, 3, and 2. We can see that the LCM is going to be 12. That's where all 3 of them come together. And 4 and 3 is going to be 12. And yeah. All right, cool. Let's move on. Let's do some quick practice problems. You should, so we can get ourselves started. So for the LCM of 3 and 5, the way we would approach this, or the way I'm going to teach you how to approach this, is that we're going to write it out. And once you get used to it and start practicing, you won't have to write it out anymore, but let's write it out for the sake of learning, obviously. So let's write out the first, let's say, 5 multiples of 3. So you should have 3, 6, 9, 12, 15. Now let's write out the first 5 of 5. So we'll have 5, 10, 15, 20, 25. All right, so let's start with some crossing out and see what doesn't work. So right off the bat, if you look at the multiples of 3, none of these are going to work because if you remember our divisibility rules, none of these numbers end in 5, so they're not going to be divisible by 3. If you look here, 5 isn't going to be divisible by 3 because 5 isn't divisible by 3. 10 doesn't work either. 15 doesn't work because 5 plus 1 is 6, and 6 is divisible by 3. 20 doesn't work, and 25 doesn't work. So our LCM of 3 and 5 is going to be 15 because this is the smallest number that both of these numbers share a multiple of. Now, if we keep going, we can later see that 5 and 3 also share the 45 and 75, but those are shared multiples. This is the least common multiple. So this is how we know it's the smallest number that both of the numbers can go into. So let's do the next one, and then you can do the last one on your own. So if you have 8 and 10, let's write out the first 5 multiples of 8 once again. We'll have 8, 16, 24, 32, 40. Let's just add one more, 48. then for 10, we'll have 10, 20, 30, 40, 50. All right, so again, right off the bat, if we remember our divisibility rules, we know that 10 cannot go into 8, 16, 24, 32, or 48. We know that 8 cannot go into 10, 20, 30, or 50. And also none of these numbers, both numbers share. So the only number that both numbers share is 40. This is the first number that both numbers share. So this is their least common multiple of 8 and 10 is going to be 40. All right, so why don't you take a second and try to solve the last one on your own, and then we'll go through it together and see if you get it right. And if not, we're going to learn. So take a second, try to figure it out. Let's see how you guys do. All right, hopefully a second to try to figure it out. Let's do it together and see if you were right. Hopefully you were. So let's start with 12. We'll have 12, 24, 36, 48, 60, and then 72. Do one more. All right, so good. Now let's do 15. We'll have 15, 30, 45, 60, 75, and 90. All right. So now let's look through it and see what will be our least common multiple. We can see that 12 and 15 don't share a 12 or a 15. We can see that they both don't share a 24 or a 30. They don't share a 36 or a 45. They don't share a 48. They do share a 60, but let's just keep going. They don't share a 75 or a 72, and they don't share a 90. So the LCM of 12 and 15 is going to be 60. Now, you didn't have to keep going, because if there's the first number that they both share, that is going to be LCM automatically. But so now we know it's 60. So if we write this correctly, we can remember that this was 15, this was 40, and this is 60. If you got that right, great job. If not, go back and see we might have gotten wrong, and then hopefully learn from that. All right, let's move on. Let's find the LCM of 3 numbers this time. Now it's the same exact process, but we're just doing it one more time with one more number. So I'm gonna do the first one. The first one. So let's write them in different colors because it might get a little confusing. So we'll have 4, 8, 12, 16, 20, and 24. We can just do one more, and 28. All right, cool. And then we can write a different one. We can write 6 in orange. We'll have 6, 12, 18, 24, 30, 36. And then we'll do one more, which is 8. This might get into other question, but that's fine. We'll have 8, 16, 24, 32, 40, 48. All right, so now let's find the LCM. Let's do some crossing. We can see that 4 is only shared with 4, so it cannot be 4. We can see that 8 is only shared with 8 and 8. Sorry, it's 4 and 8, so that can't work since 6 isn't shared. We have to make sure that all 3 numbers have the same LCM. 12 only works with 6 and 4. 6 only works with 6. 16 only works with 8 and 4. 18 only works with 6. 20 only works with 4. 24 works for all of them. And if you really wanted to, you could stop right there, since that is the first number that they all share. So the LCM of 4, 6, and 8 is going to be 24. All right. It cannot be the rest of them because even if they did share them, it wouldn't matter. They would not be the LCM. All right. Let's do. All right. Why don't you guys do the next 2? Take a second to do the next 2, and then we'll come back and do them together and see if you're right. All right. So hopefully in a second, we'll try to solve the next 2. Let's do them together. So if you know your divisibility rules, you'll know that none of these numbers don't. These numbers. It should be easier to find the LCM for these numbers. So let's take a look at this. So if we have 5, right? We know that it goes 5, 10, 15, on and on. Now, if you look at this, if you have 45, we can see that 45 is not divisible by 10, but is divisible by 5, but that doesn't matter. If the number isn't divisible by 10, so this is not the LCM. 45 cannot be an LCM of these 3 numbers. So what if we What if we doubled it? We get 90, right? And we can see that 90 is divisible by both 10 and 5. So therefore, this is the first number that all three numbers are divisible by. So the LCM of 5, 10, 45 is 90. You don't even have to write it out to figure this out. But this is how a quick way you can figure it out is that let's just add 45 to 45 once and see we get 90. And then this makes all three numbers all three numbers factors of 90. If we really wanted to, we could write it out. I'll write it out real quick. So we have 5, 10, 15, 20, 25, 30, 35, 40. Oh, wait. Let's not do that. Let's just do it real quick. So if we have 5, we'll have 75, 80, 85, 90, 95. And if we have 10, we'll have 70, 80, 90, 100. Again, I'm just starting from a later number, so I don't have to write it out like a million multiples. If we have 45, we have 45, and then 90, and then don't ask for the next one. So if we do the math, well, if we figure it out, we can see that 75, no, 75 doesn't work, 80 doesn't work, 85 doesn't work, 90, yeah, they'll have the same, 95 doesn't work, 100 doesn't work, 80 doesn't work, 70 doesn't work, 45 doesn't work, and so there you go. The LCM is going to be 90. Keep in mind the LCM is different from, LCM is a multiple, but if you have multiples that share after the first multiple, they're still multiples of the number, but they're not the least common multiple, the lowest number. So that's what we're trying to figure out, and this is going to be helpful for fractions when we go into that later on in the course. So let's do 14, 14, 21, and 7, the last one. So let's find the LCM of 21 first. Let's start with the bigger one. We can do 21, 42, 63, and 84, and 105. Okay, that's what I thought. Okay. Now let's do for 14. We'll have 14, 28, 42, and 56. And then let's do for 7. Well, it's 7, 14, 21, 28, 35, 42, 49. All right, now let's find the LCM of these. It's not going to be 21. 21 is only shared by 7 and 21. It can't be 7 or 14, therefore. And then, okay, it can't be 28, since 28 is only shared by 14 and 7. It cannot be 35, only shared by 7. It cannot be 40. And it cannot be... Okay, yeah, so now it cannot be 49. But now we can see that now we hit the number that they all show, which is 42. So our answer is 42, so we know that these are not going to be the LCMs. So the LCM of 14, 21, and 7 is going to be 42. So hopefully you got those right. If not, it's all right. You can go back and see what might have gone wrong, and then that's how you'll learn. Okay, so let's move on to our final. Well, before we move on, let's do some quick practice. Then we do our final topic. So let's find the LCM. Well, you guys will find the LCM. It's going to be all you. Of 9 and 16. So take a second, pause the video, and see what you come up with. All right. All right, so hopefully a second to pause the video and figure out what your answer might be. I'm going to pull up my calculator real quick because I don't know my factors of 64 that well. 16, excuse me. Okay. Let's do this one. So I'm going to start from 108 because I already know the answer. So if we have okay, you know what, let's do that. All right, so now let's do some practice on our for you guys. You guys do some practice. So let's do the LCM of 9. So let's do LCM of 9 and 12. So take a second, pause the video, and try to figure that one out, and then we'll see if you get it right. All right. Hopefully a second to pause the video and try to figure that one out. So let's do this one together. We can have 9 here, and then we'll have 12 here. So let's do 9 first. We'll have 9, 18, 27, 36, 45, 54, 63. All right, we can stop right there. And let's do 12 now. We'll have 12, 24, 36, 48, 60. Let's do our LCM. Let's check real quick. 9 doesn't work, only goes for 9. 12 doesn't work, only for 12. 18 doesn't work, only for 9. 27 doesn't work, only for 9. 24 doesn't work, only for 12. 36 is going to be our LCM because this is the first number that they both share. So your LCM of 9 and 12 is going to be 36. If we got that, great job. If not, go back and see where we make it wrong. It's all good. Let's do one more together and then move on to our last topic of discussion for LCM. So let's do 3 numbers this time. Let's do the LCM of 6, 7, and 8. That's annoying. That's not really nice. Let's not do 6, 7, and 8. Let's do let's do 6, 7, and 3, 6, and 7. All right. Take a second, pause the video, try to figure it out, and then let's see if you get it right. All right, hopefully a second to pause the video and try to figure it out, and let's do it together. It's gonna be the last one together. So let's do 3. So we have 3, 6, 9, 12, 15, 18, 21. All right, now let's do 6. We'll have 6, 12, 18, 24, 30, 36, 42. 48. All right, now let's do 7, 14, 21, 28, 35, 42, 49, 56. All right. So if we're given this situation, we can see that if you just look at this, we can see that none of them match. So if you get that situation, because if we take a look right here, let's just look. We can 3, 6, 9, 12, 15, 18, 21. None of them match none of them are multiples of all 3. So if you get the situation, you're going to have to keep going for one of them, and it's going to be the one that you're falling short of. So in this case, it's going to be 3 since we end at 21 here, and then 21 doesn't match with any of them, and then anything before that doesn't either. So we're going to keep going. We're going to go to... Let's just keep going. Let's see. So we'll have 24, 27, and I'm gonna put a dot, I guess. And then we're gonna work our way down to 36, 39, 42, and 45. So now let's take a look. So we already discovered that none of these will work. This doesn't work. This can't 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 work. And none of these can work. So now we're left with this. 36 doesn't work anything for this one. 39 only for this one. And then we see 42. We finally reached it. Is going to work for all of them. So 42 is going to be our LCM of 3, 6, and 7. If you got that, great job. If not, it's all right. Go back and see where you're going wrong. So now let's move on to our last topic of discussion for LCM. And this is going to be using prime factorization to find LCM. So I'm going to teach you this. We're going to go over how you do this. So we're going to do a quick practice problem first, but I'll teach you. We'll use some easy numbers. We'll do 8 and 5. Okay. So if we're using prime factorization, you should remember how to do this. We already did this. It's going to be 4 and 2. And then 2 and 2, and then 5 is just 5. So here we have 2 cubed times 4, and then we have 5. So what we will do is, okay. So what we will do is that we have these 3 numbers, right? So the way we do this is that we know that, let me write this in different different color, so we can differentiate. So we have 5, and then this is just times 5. So what we will do is that we know that the prime factorization of 8 is 2 cubed. It's just 2 cubed, excuse me, not times 4. I don't know where that came from. My apologies. It's just 2 cubed. So we know that this is just 2 cubed, this is just 5. So what will happen is that we're going to multiply 2 cubed and 5, and this is going to get you 40, which is the LCM of both of these. So this was an easier one. Let's go on to a more challenging one that you'll have to do something a little bit different. So let's go pretty big. Let's go 24 and 60. So let's let's do prime factorization of 24 and then of 60. I like that color. So let's do 60 first. We'll have 15 and 4. Again, you can start with any number you really want, but whatever works for you. So then we have 2 cubed times 3 times 5. And then for 24, we can break this down into 12 and 2, 4 and 3, 2 and 2. So then for 24, you'll have 2 cubed times 3. So the way we're going to find the LCM of both these numbers is that we're going to take the highest power from each. From one of them, excuse me. So we're going to take the highest power of both of them. In this case, the highest power is 2 cubed. So we're going to have 2 cubed, and then we're going to take everything else that they're sharing. So we have a 3 and a 3. So if both have a 3, so we make that into 1 3, and then they have a 5, and they multiply that by 5. Since 60 only went with a 5, it automatically goes into the equation. If they both have the same number, they go into the equation as one of them, as 1. So you won't have 9 here. You just have 1 3. And then you take the highest power of both of the prime factorizations and you plug it in here. So then when we multiply 2 cubed, 2 cubed is 8 times 3 times 5. You will get 8 times 3 times 5, and the answer to that, this is getting really small, and I apologize, but so the LCM of these two numbers is going to be 120, because 8 times 3 times 5 equals 120. So this is how you would use prime factorization to find LCM. It's kind of neat. Okay, let's do one more together, and then you do one on your own, and then we'll be done for the video. All right, so let's find the LCM. Let's do a little bigger numbers. We'll do let's do 64 and 72. All right, so let's work this one together. So if we have 64 over here, let me write that a little bit. Give myself some more room here this time. So if we write 64 over here, and then we write 72 over here. All right, let's factorize 72 first, I guess. All right, so we'll have, we can do 9 and 8, 4 and 2, 2 and 2, 3 and 3. So we'll have 2 cubed times 3 squared, and then there you go. That's your prime factorization for 72. Now if we do 64, we can do, I don't know, 16 and 4, 2, 2, it's going to be 4, 4, not 4, 2, excuse me, it's going to be 4, 4. I promise I can do math. So it's going to be 4, 4, and it's going to be 2, 2, 2, 2. So we'll have 2 to the 2 to the 6th. And that'll be your prime factorization for 64. So now, like we said, we take the highest power, and then so in this case, our highest power is going to be 2 to the 6th. So we take 2 to the 6th, and we take and then we can see that 72 only has a 3 squared. That's not that has the same base. So this, we don't use this because we can take the highest power of the same bases, which is 2 to the 6th, and then we take this because this is by itself. We take any number left over. So our final equation that we're going to multiply, final expression, excuse me, we go 26 times 3 squared, and you plug that into the calculator, and you get 576. So this is going to be your LCM of 64 and 72. Pretty neat, right? All right, let's do one final one. You can do this on your own, and then we're gonna call it a night. We'll call it a video, not a night. Depending when you're watching. So let's do. Okay, let's do 21 and 49. All right, take a second, pause the video, and try this one on your own. Good luck. All right, hopefully a second to pause the video and try it on your own. Now let's do it together. Let's use orange this time, why not? So let's do 21 and then 49. So let's start with 49. We have 7 and 7. Pretty straightforward for that one. And then for 21, oh, this is an easy one. Oh, I gave you an easy one. Okay, we'll do one more. We'll do one more. And then for this 21, we had 7 and 3. So now our prime factorization for this is going to be 7 times 3. And then for this one is going to be 7 squared. Let me write that in the right. Oh, shoot. I apologize. I write that in the right color. 7 squared. Okay. So now, again, we take the highest base. In this case, it is 7 squared. They both have the same base, but this one only has a power of 1, so that doesn't count. So then we do 7 squared times 3, which is 49 times 3. And then our LCM of 21 and 49, you should have gotten 147. There you go. All right, let's actually do one final one, and then we'll call it a video. I know I said that like 3 times, but let's do one final one. Let's give you a big one and an actual challenging one this time. So we'll have the LCM of 46 and 66. All right, good luck. Pause the video, see if you can figure it out. All right, so hopefully in a second, pause the video and figure this one out. Let's do this one together now. So let's take 46 and let's take 66. Let's factor this one first. We'll have 11 and 6, and then we have 3 and 2. And then we do this one now. 46 goes into 46 besides 2. I don't think anything does. So we have 2 and 23. So the prime factorization for this is 2 times 23. And then for this one is 11 times 3 times 2. All right. Now, you're probably like, wait, none of them have any bases or anything. That's totally fine. So since none of them have any exponents, you're just going to multiply everything together. Multiply this by this, and then your answer, if you put in a calculator, is going to get 1,518. That's an awful 8. I apologize, but that's what your answer is, 1,518. Got that. Great job. If not, go back and see what I got wrong. And yeah, so that was today's video. It was an LCM. Sorry if it was a little longer, but it's an important topic when you get into fractions. So hopefully you learned something new, and hopefully if you knew it, you refresh your memory. So thank you for watching. Make sure to leave a like and subscribe. More videos coming out to you guys for pre-algebra. And make sure to check out our website, see our other courses, other teachers, and other great resources. And feel free to email us any questions at our Gmail right here. And then other socials are in the description box below. So check out our posts, check out our TikToks and videos, like, share, comment, anything to help our community grow, and so we can help you guys. You help us, we help you. So thank you again for watching, and I will see you guys in the next video. Goodbye.